Hi, this is just a quick demonstration of iLunolet application, which is a scientific simulation of a spacecraft flying around the moon and taking off, landing, docking with a space station, undocking, landing, doing all of that. It is scientifically accurate. It actually does all the calculations accurately, simulates a spacecraft that's running on a mix of liquid oxygen and hydrogen. And when you start the application, it gives you a little overview of the controls. And let me go ahead and do the overview of the controls as well. But I'm actually going to start it. So anytime you pause the application, the overview of the controls is shown. This can be turned off in settings if that's something that annoys you and you already know what you're doing. So I'm going to just start it, and basically this is the moon, and you can move it around and you can zoom in and zoom out. As you can see in the middle of the screen there's a scale, so as you're zooming in or out the scale changes together with your picture. And then on the left hand side we have, so I'm sorry, before I go to the left hand side, so this is obviously the moon, and the red thing, which you can probably not see very well in the video, is the spaceship, and the blue thing is the space station, which already started moving a little bit, as we can see. It's running real time, so we have a clock here up at the top, and been flying for 45 seconds. The ship is standing on the surface. The station is moving, and you can accelerate the time, which is particularly useful during orbital maneuvers that require several orbits around the moon. So you can accelerate the time by moving the slider. And can you zoom in a little? And you can accelerate up to 60 times the normal rate. So basically, every second would be a minute in real time. So anyway, so what we have is, So what we have is, on the left-hand side we have the ship flight parameters. On the right-hand side we have the station flight parameters, the telemetry. Then we have the scale in the middle. On the left-hand side we have the throttle control, so we have a 100% button and a 0% button, and the +10, -10, +1, -1, and +0.1, -0.1%. So this way you can control the throttle. And then on the right-hand side we have controls for the throttle vector, so basically where you're pointing your engine. And and then here we have a pause button. And we also have a home button, which allows us to restart the application and go back to normal. In addition to that, if you double tap, it just, if you really get yourself, you don't know where the moon is, you double tap, it puts the moon right in the middle of your screen. So as I said, you can easily turn off the controls by going into settings. You can easily turn off the help by going into settings and changing the settings for this application, as well as other settings that you can change. So if you go here under iLunolet, you can go and turn off show help on pause. And now if I were to restart the app, and now as you can see, this is not showing. The other settings, as long as I'm going to go there into settings, I just wanted to show you what's available. The other settings are always start paused, refuel at the station, which means that when you get to the station, put the full tank of fuel so you can go back, unload cargo at the station, and this could simulate that you're actually bringing something to the station, some useful things. And then here you can set up the ship parameters, including the cargo. So if you put some cargo here, it will unload it at the station if this is on. And then the space station parameters. So the space station is in a circular orbit at 100 kilometers, and it starts at 0 degrees, which is right at the top of the screen, but you can control it. And then for the ship, you can also change the position, the height, or the altitude. the vertical speed, the horizontal speed, the net mass of the ship, the fuel, the weight of the crew, which is a weight of the person in a spacesuit, and the cargo. So, and one more thing before I actually show how the program works is I wanted to show you what the inspiration for this was. And the inspiration for this was a video of how the real Soyuz docking actually happens and what the interface looks like. And I found a YouTube video, and basically what the way it works is they actually have on the screen, you can see the image, so you can see what's going on, and then overlaid on the screen, it's kind of black and white, are the flight parameters that are necessary to dock successfully. And that was the inspiration for the look and feel for this application. I wanted to make it look like not a toy, but rather like how it might look in a real spaceship. So anyway, so if we go back and zoom in a little bit, and let's just try to take off. So what I'm going to do is I'm going to unpause it, and as we can see, the station is moving. So I'm going to turn on the engine, and first slowly. You can zoom in really deep, and that comes in really handy when you are actually docking or landing. So right now my scale is 2 kilometers, and I can go even more, and I can make it 200 meters, and things are going to start moving a lot faster like that. And right now let me just go into a low moon orbit, and because there is no atmosphere on the moon, you can go into an orbit that's really low, just a few kilometers, and there's no mountains in the moon that are very high. So so the goal is, let me stop for a second, and can you zoom in on the ship parameters? The system calculates for you the orbital speed at the altitude where you are actually flying right now. So if you get your horizontal speed equal to your orbital speed and your vertical speed being equal to 0, then you are in a circular orbit. So if you look at the space station, that's exactly what it is. The vertical speed is 0, the horizontal speed equals to the orbital speed. So what we're going to try to do is we're going to try to get into a low orbit where our horizontal speed equals to the orbital speed and a vertical speed equals to 0. And it's going to take us a few minutes to get there, but hopefully not too long. So as you can see, our horizontal speed is increasing. It's about 750 meters per second, and the orbital speed is about twice as much. So I'm going to try to adjust it a little bit so that our ship is not going to fall to the surface of the moon, because we're flying. Our throttle angle right here is 85 degrees now. So it's mostly throttling to the right, sort of, but at 90 degrees, but a little bit to keep the ship from falling down. And we're getting closer to our orbital speed now. So I'm gonna stop talking and driving, and just make sure that we don't do anything dumb here. So let's see. And we're getting close, and when I'm going to get the speed pretty close, I'm going to turn off the engine. So we're about 8 meters per second short, and now I'm going to do it with some fine tuning. So instead of doing 100% throttle, I'm just going to do a plus 10% and go towards a little bit closer, and now plus 1, and now plus 0.1. So I want to get exactly to the horizontal speed to equal my vertical speed, or at least very close. So this is probably close enough. And now I have the vertical speed, which is really messing up my horizontal speeds. So I'm going to turn the ship upside down, and I'm going to get rid of that vertical speed, or get it close to 0. And I overdid it just a little bit. Okay. And now let's do the final adjustments for the horizontal speed. And this is probably close enough. So if I zoom out now, we can see that we're flying in a really low moon orbit, and we're flying under the space station, and if I were to increase the time, we're going to see that we're actually not going to go anywhere. We're going to stay at that orbit, and we're going to just fly. We're going faster than the moon because of the fact that at the lower altitudes the orbital speed is higher, and also the distance that we need to travel is smaller. So we're actually going faster than the station. And also notice that if you're zoomed in, then it centers on your ship and everything is rotating around the ship. But if you actually zoom out enough, it actually sort of keeps the moon stationary, so you can see your orbit in the grand scheme of things. And it actually is really, really, you don't even notice it, but it's very intuitive when you use the program. So now that this is really great, how about we try to get to the I don't know if we should really dock. That docking might take a good 40 minutes, and including the accelerated time, and in real life it might take several days to actually catch on with the station. But what I'm going to do now is I'm just going to try to put it in a little elliptical orbit, so you can see how things are when the orbit is a little bit more interesting. So so we're flying right now at a normal rate of time, and I'm just going to turn on the engine and get my horizontal speed slightly higher than my orbital speed. And let's get it like so, for example. And now, you know, we can sit here and watch for a very long time, but thankfully we have the accelerator, and we can see that very slowly at first the altitude is going to start to increase because our orbital speed is higher, and we're actually going into an elliptical orbit now. So our altitude, which was about 3 kilometers, now is already 30 kilometers, and it keeps going up. And so now we put the ship into the elliptical orbit. The orbit, as you can see, is slightly higher than the orbit of the space station. And now it reached the apogee, and actually hasn't quite reached the apogee, but it's about to reach the apogee. Now it's going to go lower, and it's going to go in that ellipse forever until we turn on the engine again and try to do something, either dock or land or crash, whichever is going to happen. And as you can see, the trail of the station and of the ship slowly fades into nothing. You know, going back to where we were, but it allows you very easily to see what the orbit is like, and that's our elliptical orbit. And I probably should have made it a little bit more elliptical. It's probably too close to the circle, so I needed to add a bit more to the speed, which I can do now when we're going to reach our perigee. Oops. So we're right about there. So I'm going to go ahead and add some more to speed. As you can see, when I turn on the engine, I don't know if you can see it, but there's a little thing here that indicates that the engine is running. And now we're going to have a really elliptical orbit. And you can see where it's going to go, but that's pretty much iLunolet, and if you want to know more about it, let me know. I'd be very happy to provide more information. Thank you.